In this chapter, we're going to talk about classes and objects. And in this particular video, we're going to get a glimpse of what classes are and what objects are. Now, I have a confusion between classes and objects as to where to start from. Should I start explaining about classes or should I start explaining about objects? But I thought it would be better to start with neither. Instead, I would start with methods. Now, if you go take a look at other tutorials, they may start by giving the definitions of classes and objects, which I feel at this point of time you may not be able to understand. My way of teaching is different. I'm going to give you a real-time example, and from that you can easily make out definitions. That makes more sense. Anyway, let's get started. Let's talk about methods. Let's say we have an e-commerce website, something like eBay or Amazon, that was written using Java. And let's say our code, our source code constitute of 2000 lines of code. It would probably be exceeding 1 million lines of code, but just for the sake of explanation, let's assume so. And the entire code is under one block. Now within this code, we might have a set of instructions spanning across 10 to 20 lines that does a particular task. For example, add product to the cart. And there could be another set of instructions that does delete product from the cart. And there could be instructions on applying the coupon, or something like make payment, etc. Now we have a problem here. We are lacking code readability. Let's say you wanted to perform the same operation, add, at later point of time. Then you're going to write this set of instructions, 10-20 lines, again somewhere over here. That's going to increase the complexity and reduce the readability. The new programmer who will take a look at your program will definitely curse you. So what is the solution? We're going to create methods. If you are aware of functions in other programming languages, that's nothing but methods in Java. So what we essentially do is we're going to take out this set of instructions that does a particular task, separate it out, put it inside another block, and we're going to name this block something like addition or something like that. And whenever we need to execute this set of instructions, instead of writing all those 10 lines, we're just going to simply call this block of statements using this name, addition. Similarly, next time you'll have to do the same set of operations, then you're going to simply call this block using this name again. That will reduce 2000 lines of code into 50 lines. This will increase the readability. Also, the code is more organized. And this block of statements that I'm talking about is nothing but methods in Java. Now let's try to form a definition of a method. A method is nothing but a set of instructions in a block that does a particular task. And that block of statements will have a name tag to it so that we can use it to execute those block of statements. Let's go to our workbench and see how this works. Open the file named classes and objects under the project classes and objects. Now I'm going to simply copy paste the code from switch statement example that we talked about earlier. I'm just going to copy the code inside this block, the main block. I do Control C and paste it over here inside this main block. I'm going to save it. Now let's say we want to separate this statement out and put this inside another block. The first thing is to take this statement. This could be one or more statements, but in our example is just one statement. We're just going to do Control X, and we're going to take that statement out of this block like this. Now what we're going to do is we're going to call this statement or statements from here. How do you do that? We need to give the statement or the set of statements a name. So for that we need to create another block using curly braces, and we're going to give it a name, something like addition. Now this block of statements is not aware of these two variables a and b, because a and b are initialized over here in a different block. So the scope of this variable are within this block. So what we're going to do is we're going to give parenthesis, something like that, and we're going to send these two variables from here. So first of all, let's put this over here and send a comma b, and since this is a statement by itself, we're going to end with a semicolon. We have sent a and b here, but we're not receiving it here. How do we do that? We're going to give the type of the variable int that we're expecting, int a and int b. Now this block of statements will be aware of these two variables a and b. We have another problem here. What's that? Whenever we execute a certain block of instructions, we're going to expect something out of it. Sometimes we don't. Here we're just doing system.out.println a plus b, and we're printing it. In this case, there is nothing that we want to give back to the block where we're calling this method from. So what we do is we say void, which means I'm not sending anything from this block of statements or from this method addition. In case if you want to send something, then you might want to use the keyword called return. We'll talk about it in detail at a later point of time. So for now, this is it. We have a proper method declared or defined, whatever you call it. There's one little twist here. Since this is a static block, we didn't talk about static block, but we will in a while. This has to be static. We'll talk about static keyword later point of time, but this is it. Now this will essentially does the same thing what we're doing here, but in this example we just have one instruction. Let's say these are 10 or 20 lines of code, then that would make perfect sense to use methods instead of writing the code over here. If you run this program, it's going to yield the same result. Let me save your time by not running it. Great. Now we understood what method is. It's essentially a block of statements that does a particular task, and we're going to give that block of statements a particular name, so that using that name we can execute that block of statements anywhere in the program. So next time we want to execute this set of statements, we're just going to do copy paste of this, Control C, and maybe we're going to put it over here. By the way, that's illegal to put it over here. Let's save the file. Great. Let's go back to our whiteboard. Now obviously we don't want the entire code to be under one file. Think about Amazon or eBay, where the source code would be in millions of lines of code. How could it be possible to manage the code if it is under one single file? Probably the entire code is split across multiple files, class files. So what we're going to do is we're going to create multiple files, essentially class files in Java. Say we're going to have a class file called product that has the methods that are related to product. For example, add product, remove product. And we're going to have another class that's going to do checkout. And this may constitute methods like apply coupon or maybe make payment. Now let's understand this in our example. So what we'll do now is we're going to take this method out from here, out of here to a different file. So for that, we need to create another class file. So let's do Control C and Control V. That will create a clone of this class. We're going to name this class as Maths class. I'm going to click Refactor. And we're going to get rid of this entire code in here. In fact, we're going to get rid of this entire block altogether. We don't need main method here. For the entire application, we'll be needing only one single main method. We'll talk about it later. But now let's move it over here first. I'm going to do Control X, cut it from there and paste it over here. We definitely will have an error here because the method is no longer existing here. So how do we call this method residing in another class? This is how we're going to do. I'm going to say somewhere over here, math obj stands for object, and we're going to create a new object using the keyword called new, and then again maths, typo error there. So what did we just do? We created an object. Ladies and gentlemen, welcome to object-oriented programming language. This is what is object. Of course, we're going to talk about it in detail in a while. Now using that object, we can call that method by doing object.addition. Let's continue in our next video. Let's continue. Not sure if you have observed or not, but we've been using classes, methods, and objects already. What does this out.println mean? Out is nothing but an instance of a class, and we're just trying to call a method inside that class. What this method does is just going to have some instructions that will print this statement on the console. And the main that we've been talking about is nothing but a method with some arguments. We're going to talk about this statement pretty soon. And in here, classes and objects is nothing but a class. So knowingly or unknowingly, we've been using all these throughout our examples. Now these variables in here doesn't necessarily have to be inside this method. It can also be inside a class within this block. Let's try to do the same thing in our maths class. So we can have int x equals 10. We can have int y equals 20, and you can have a method. By the way, we don't need to have static in here. Should have fixed it in our previous example. See, we don't have any error here. That means we're good. I'm going to do Control S, save. We're going to create another method. Void, let's do product of x and y. We're just going to simply copy paste this line and do it's x multiplied by y. Let's do Alt Shift and F. Alt Shift and F, that will indent the code. That looks better. Now using this object, you can also invoke this method. Now note that we don't have any arguments in here. We'll talk about syntax of methods pretty soon in our next video maybe. But yes, this is it. Let's try to understand a little bit more about classes and objects. Why is this called an object? This is somewhat similar to real-world objects. If you're talking about real-world objects, it has two things. One is the state and the behavior. Let's think about a dog. A dog will have a state of height. it can have a state of breed, or it can have a state of color. Coming to its behavior, a dog can walk, or maybe running, or maybe sleeping, etc. Let's take another example. Let's talk about a car. A car will have a state of brand name. A car will have a state of number of seats available. Coming to its behavior, start the car, stop the car, or change the gears, etc. An object in programming world does have a state and a behavior. When I'm talking about a state, those are nothing but the fields that we initialize or declare here. Coming to the object's behavior, the methods that we write here are nothing but an object's behavior. We can have multiple objects from a single class. Let me explain you in detailed fashion. Let's go to whiteboard. Let's say you have a land of 10 acres. Now what you want to do is you want to construct 100 houses. All these 100 houses are constructed based on one single design. This design is nothing but a class, and all these objects that use this design are nothing but instances of this class or objects. So now let's try to form definition of a class and an object. A class is nothing but a blueprint of an object, or a template using which you will manufacture multiple objects. Whereas an object is an instance of a class. It will have the state of number of bedrooms available, or the color of the house. It can have a behavior of add tenants, remove tenants, check mailbox, etc. Let's go back to our workbench. Just as in our example, we created multiple objects, we can also create multiple objects of math class. For example, we can say object 1. So essentially what we did here is we have two objects but are identical. Objects doesn't necessarily have to be identical. Let me explain you what I mean. Again, let's go back to our whiteboard. Although all these houses are based out of one single design, that doesn't mean all these houses should stay identical. They can vary in terms of color, number of bedrooms available, etc. So when we're trying to create an object, we'll also set its state. And we'll give the values like number of bedrooms available or the color of the house, etc. Going back to our workbench. Sorry about the frequent switching. Now let's get rid of this. So how do we set the state of an object? We used constructors. Let's talk about it a little bit. A constructor will have the similar syntax as to that of methods. We haven't talked about the syntax of methods and constructors. We will in our next video. But constructor will have the same name as to that of the class name in which it is residing. So we'll simply say maths, and then that's it. We have a constructor here. And instead of setting these values in here, we're just going to get rid of all these initializations, and instead we're going to send parameters to this constructor. We're going to say int, say d, comma int b, all right, let's say k. X equals d, y equals. Now this should bring us an error here. So what's going on? Whenever we create an object, it will definitely call the constructor first. If you don't create any constructor, by default a default constructor will be considered. What's a default constructor? A constructor without any parameters and without any content inside it is nothing but a default constructor. So what is the purpose of it? Let's say you have a class called dog, then let's say you have a field called height. If you don't set anything, constructor will do that for you. It will give the initial state of the dog. It will set the default value. It will set the value to be 0 if it is an integer type. Now since you gave your own constructor with parameters, the default constructor will no longer be considered. You'll have to write another constructor which does not have any parameter. If you don't write one, then at least send some parameters in here with object. So we'll send 10 and 40. So the moment this statement gets executed, we'll set the state of this object as x equals 10 and y equals 40. So now think about it in this way. Let's say this is a house class. We can set the number of bedrooms and the color of the house using a constructor. And throughout our program, we'll use those particular fields. So what do I mean by that? Had this been a class called house, then you can have an object, a house object with say number of bedrooms 3, and you can have color as red. We can have another object, object 2 of house, with number of bedrooms as 2 and color as green, something of that sort. You can have as many objects, you can create or manufacture as many objects as you can. So that's what is the job of a constructor. Now I hope it makes sense. You can run the program, you can play with this program in whatever way you want. You can also say object dot product to print the statement. Alright, see you in my next video.